here is the counting circuit. We'll count down, up, and down. Now to explain how it works, the circuit diagram I have here is for the 2 digits, because I decided to make 2 digits, and basically it's the same, except it adds on to this part, it doubles. But first you have the low side switch, which is a normal button, except it is passively high. But when this is clicked, it's low. So for every time you click this button, this NAND gate, or which is acting as an inverter, is powering this oscillator in here. Then this will power here with the capacitor that will then give voltage this when it's full, making it so this isn't getting volts, so it doesn't fill up, but then this does. So this is high coming out of here, so this does again, creating square waves here. Now this square wave or oscillating current goes into the 4017, which is a chip that can read the oscillating current and divide it by 10. It can also do much more, it can count. But in this scenario, it is only divided by 10. So then the 4510 will read that current as a oscillating current. And for each time it oscillates, it'll count up 1 digit. Although the 4510 can only do that in binary. So in order for it to be compatible with the 5011AS, we need a 4511, which will read the inputs from the 4510 and transition them into compatible outputs for the 5011AS. So if it wanted segment F to turn on the 7-segment display, it would power in pin F from output pin F. And each pin works in the same way. And then there's these 2 ground pins which are both connected. But for my DDR, I thought it'd be cool to add a second digit, and it won't be too complicated. Now, for the second digit, you use a new pin, the carry out pin, and the carry in pin. The carry out pin, which connects from the 4510 to the second 4510, will tell this 4510 to start to count once this 4510 has reached the digit 10. So then, once it is at 10, this will become 0, but this 5011AS will become 1, making 10. This works through the carry-out pin, which is fed into this carry-in pin, and this carry-in pin will then power this 4511 again, and repeat the entire process. Although there's also the reset button, which will reset the 5011ASs at 0, or 99 if you're counting down. There's also the up-down switch, which gives you the ability to count up and down. As you can see here on the counting circuit PCB, you have the off-on switch and the up-down switch. Now the off-on acts as the reset button, and the up-down switch changes it, so right now it's on up, but if I wanted to count down, I would simply switch it to the down, and it would commence to count down. And that is how the ACES counting circuit works. I hope you enjoyed the video. Thank you.